Okay, good afternoon. Right, so today we want to finish the second part of database, that is analysis, okay? Analysis and modeling part. Uh, so remember now we are in topic 8. We have already done the introduction to DBMS, which we discussed last time. And we just started the data analysis and ER modeling, okay? So we want to possibly finish it today, right? So then we have 3 more topics: designing, normalization, SQL. Right. So let's continue our discussion on analysis. So remember, when it comes to developing software in structured approach, we need to understand the process related requirements, data related requirements. Process related requirements we have already done. Context diagram, data flow diagrams, and process descriptions. And last class, we start discussing how to analyze and model data related requirements. Okay. So un understand and analyze and model the requirements, conceptual data model. That is what we are currently doing. So then you can go to the logical designing, physical designing, and then we can develop the database. And of course, other programs that can connect to the database. And then of course, the deployment and so on, maintenance and so on. Right. So right now we are here. Analyze, understand the requirements and model. Okay. Right. So we have 3 type of models. Conceptual model, that is what we are doing right now. Then logical model in the early part of designing, physical model in the latter part of designing. Okay. So conceptual models model the requirements. The logical model is the solution at logical level. Physical model is the solution at more technical detail level. Right. So in conceptual model, we model entities, relationships, and of course the attributes of the entities. In logical models, we use slightly different terminology, but pretty much the same: table, relationships, fields. Right? And physical model, we are more interested in data files, index files, and performance optimization, security, and so on. That is designing. And then implement it using SQL. Right? Create your tables and so on. Still, we are not creating tables, right? We just model it. We just model the requirement. Right. So we start discussing conceptual ER modeling. So we discuss what is entities. Entity is a major concept in our domain or problem space. Okay. It depends on what kind of a system we are looking at. Sometimes entities are called entity sets. Okay. Employee entity, department entity or department entity set, project entity set. If it is student management system, student, course, teacher, right? So we subdivided for our ease of understanding entities into 3 types: living physical, non-living physical like vehicle, product item, and conceptual thing like payment, order, course, right, and so on. So then we discuss how to model entities. So we identify 2 type of entities: strong entities and weak entities. Strong entities are modeled as normal rectangular shape, whereas weak entities we model as double line rectangles, double rectangles. So strong entities are our major concept. Weak entities are related to us indirectly, like parents of a student, spouse of a employee. Okay. Double line, single line. So then we start discussing about attributes. So attributes are the properties of an entity. Right. So we categorize again in attributes into different types. Right. So we discuss what is mean by identifier attribute. We underline the identifier attributes. So that help us uniquely identify instance of that entity, like employee ID, student registration number. So make sure you underline it. So then we moved on to stored attribute versus derived attributes. So stored attributes are usually we store it, like name, contact number, and so on. A derived attribute we can derive from one or more of our stored attributes. Like as long as you have the date of birth, you can derive the age. Okay, something like that. If you have the price, mark price, and discount percentage, you can derive the selling price. Okay, something like that. Right. Derived attributes are used, we mark with dash ellipse, dash ellipse. So then we look at composite attributes. So the composite attributes are the attribute we can subdivide into sub attributes, like address we can subdivide into number, street, city, something like that. So then we moved on to multi-valued attributes. So that is where we stopped. The multi-valued attribute means there's a possibility of multiple values for that attribute, like skills, contact numbers. Okay. So maybe you have a particular employee has multiple contact numbers, multiple skills. Right? So we use double elliptic shape. Right. So now we move on to the relationships. So relationships are logical connection between entity. A relation is a logical connection between entity. Right? Not every entity is related with each other. Some entities are related. Okay. For example, student can be related to a course. Student studies for that particular course, follow a course. Employee work for a department. So you can see naturally there's a connection, relationship. Customer places an order. So that order has a customer. Customer is related to order, order is related to customer. And maybe there's a payment for that particular order. Okay. So those are called relationships. So with your experience, common sense, logical thinking, you will be able to identify whether there's a relationship between two entities. So you must not mark, if there's no logical relationship, don't mark it as a relationship. At the same time, don't miss relationships. If there's a relationship, you must model it, which need bit of practice, bit of experience. Okay. Right. When it comes to relationships, this is how you represent a relationship. You have the entity or two entities. There can be relationship between three entities or relationship between instances of the same entity also. So we will look at those special cases later. Okay, something like that, something like that. But we will be looking at, right, only binary relationship for the time being. Binary means two entities. Right. When it comes to relationships, so this is a very easy topic. Therefore, I'll be doing it fast because I don't want to waste time. Right? Because there are some complex topics like programming later on. And designing part I will be doing slowly because designing you need to think a lot of things like normalization and so on. And this is straightforward, right? Right. So when it comes to relationships, we are interested in two concepts of the relationships: cardinality or the multiplicity of the relationship, the degree of the relationship. So whenever there's a relationship, think about what is the cardinality of that relationship, what is the degree of that relationship. Right. So this is how you model relationship. So you have the entities, and this is how you represent the relationship. And you can give a name like student register for course. Make it descriptive and short. Maybe just one word is enough. But often your relationship will have a verb. Not a must, but naturally most of the time there will be a verb. Right? employee work for a project. Okay. So this is how you represent your cardinality or the multiplicity, one to one, one to many, many to many, right? One to one to many, and so on. That we will discuss later. So then this is optional. Optionally, you can have role name. Very rarely you will see role names. You can have role names in both ends or in one of them. But this is very rarely used, but you must know that if you want, you can have it. So then what is mean by if you want, if it add value, if it is useful, add the role name. But if it is obvious, don't add role name. Right? Right, role name I will explain. Okay. So this is a big picture. So these are some examples. These are some examples of relationships. Of course, these are all binary relationships. And we can see often you will have a verb here that make it very natural because you remember in second paper's part B, always you get a question. And often they ask you to draw the ER diagram. So then make sure this is a noun. This has a verb, right? Make sure you specify your multiplicity. And role names are optional. Often we don't show it. You can see option. Here we have shown the role name. But all the other cases I have skipped it. So what is mean by role name? For example, when lecturer supervises a student, the lecturer play the role of a supervisor. Lecturers are supposed to deliver lectures, but when a lecturer supervises a student for a project or something, so then lecturer play, play a special role called supervisor. So, but this is natural thing, right? Customers making order, so then you don't because then the role is also customer, right? Employee work for department, it's employee. So then you don't need to show it. But if the relationship is due to special role, just specify it. Just specify it because it makes sense, right? Right. So if you have any questions, you need to ask. Okay. If you have any questions, you need to ask. Right. So that is how you specify the relationship, right? So this binary relationship, two entities, relationship name, optionally so role name, and of course the multiplicity. Multiplicity. Right. What are the possible multiplicities? Another name for multiplicity is cardinality. So you must familiar with these words, right? Multiplicity or cardinality of a relationship. So what is mean by cardinality? So cardinality is one instance of X, how many instances of Y are related? For one instance of X, how many Y instances are related? And for one Y instance, how many X instances are related? So that is called cardinality. So remember, you must give the best answer in the world. Best answer. Don't settle for second-hand answers, right? Third class answers. Be a first class person. Okay. So that is why if you go for a degree program, so some students get first class. So when we have a batch of say 100, say 80 students, sometimes only one student get first class, maybe just two students, sometimes no students. But try to be that first class student. Okay. So your answer must be the world's best. Okay. So therefore, what is mean? If someone asks what is multiplicity, what is your answer? So multiplicity is related to relationships. Say this is my X and Y entities. So multiplicity of relationship between X and Y is how many instances of with one instance of X, how many instances of Y are related, and with one instance of Y, how many instances of X are related. So that is called multiplicity. Okay, right. So what are the possibilities? So there are three possibilities. So there's a possibility of one-to-one relationship, one-to-many relationship, many-to-many relationship. Okay. Sometimes you may call it many-to-one, but many-to-one, when you look at it from other side, it is one-to-many. So therefore, you don't need many-to-one, because many-to-one is also one-to-many from other side. So therefore, we have three possibilities: one-to-one, one-to-many, many-to-many. So in our real world also, all our relationships are either one-to-one, one-to-many, or many-to-many. There's no other type. Okay. Just look at the real world, because we are modeling real world scenarios, business scenarios, any other scenarios, because software is developed for the real world people, for real world business and other activities. Right. What is mean by one-to-one relationship? So remember, your definition has two sides. This side, you need to talk both. Don't just explain one side. No, you need to explain this side and this side. Otherwise, your answer is not correct. Some people are so lazy, they just explain one side, then stop. That means they are laziness. Right? What is mean by one-to-one relationship? Say we have entities A and B. So we say that the relationship between A to B is one-to-one if one instance of A is related to one instance of B, and one instance of B is related to one instance of A. So that one we don't write it, but one instance of A is related with one instance of B, and one instance of A is with B is related with one instance of A. So then only it is one-to-one. Sometimes we just call it vice versa. Anek katarat hari. Okay. So that means one instance of A is related with one instance of B and vice versa. That means one instance of B is related with one instance of A. So that is called one-to-one relationship. Have you seen one-to-one relationship in real world? Can someone tell me? Two entities, and between those entities, there's one-to-one relationship. Anyone? Anyone? Don't worry, you can make mistake, right? If you know everything, you don't need to attend this session, right? Just give me example that you think that it is one-to-one. Anything, anything, your family background, your neighbors, environment, business, school environment, among friendships, friends, relationship, which is one-to-one, one-to-one. Because if you make a mistake, I can correct you. I can correct you. Otherwise, you will make that mistake going to the. Now, you guys are not talking, right? So, education needs two-way communication. So, how do you uh, find your issues if you don't talk? Right? Exam is one-way communication, but education must be two-way, right? So, can you give me an example of one-to-one relationship that comes to your mind? No, nothing. For example, country and president. So one country has one president is for one country. Have you ever seen a country has two presidents? Have you ever seen that that particular president is a president of two countries? I haven't seen. Okay. Yes, person and identity card. So that is a very good example, classic example. So every person must have one ID, and one ID card is for one person. So that is one of the classic example. Okay. When you take a tournament or something, one player is supposed to play for one team. Right? Or one captain is supposed to captain one team. One team is supposed to have one captain for a particular game. Right? One-to-one relationships are rare. That is why you find it difficult to find. Yes, that is correct. Rare, very rare, but there are. Okay, right. Husband and wife, that is another one-to-one relationship because otherwise it's illegal. Of course, in certain religions, sometimes those are allowed, but very rarely practiced. But in general, legally, one person can be married to only one person legally. Country can have only one national flag. One national flag is for one country. Rare but exist. Right now we move on to one to many. One to many relationship. Now again you must give a very precise definition. So we say that two entities A and B having one to many relationship if one instance of A is related to many instances of B and one instance of B is related to one instance of A. So give the full definition. Okay. Sometimes we call it zero or many here, but in general many. Okay. In general many. So one instance of A is related with many instances of B, and one instance of B is related with one instance of A. You must tell that because that then only it is one to many. Otherwise, it is many to many. Sometimes this many you can call it one, zero, one, and zero many. That is optional. Okay, don't worry about that. Okay? Now, can you think of real world examples? Real world examples, which is one to many. One to many. Don't think about extraordinary situations, right? Just normal scenarios. Actually, most of the relationship in this world, those are one to many. I would say more than 75% one to many relationships. More than 75% of the relationships. So sometimes if you tell a random relationship, there's a high chance your relationship is one to many. A mother and children. Mother can have many children, but one child can have only one mother. Now don't think about test tube babies, okay? One school can have many teachers. One teacher belong to one school at a time. Yes. So usually teacher is not assigned to many schools. Correct. Okay. So mother child is the classic example. And department can have many employees. At a time, employee work for one department. Usually, right? One department. Okay. Right. So those are called one to many. Most of the relationships are one to many. Most of the relationships. So now we move on to many relationship. So again, make sure you, when you define, you give the definition to both sides. This way, this way. Always we start with one instance of A is related with many instances of B, and one instance of B is related with many instances of A. Or you can say vice versa. So then only we say it is many to many. Right? Then only we say it is many to many. Now think about many to many relationship. If it is wrong, don't worry. At least you can correct yourself. That is why you need to attempt. Otherwise, you will keep that wrong impression with you when you go for the exams also. Just give me one example, many to many. So it can be from anything, physical world, living things, conceptual things, or mixture of those. But it must be two entities. You must give me two entities. Many to many. Actually, many to many are not rare. It's not as rare as one to one. One to one is the most, like, rarely you find one to one. No one. For example, employee can work for many projects. That is often happen in software development projects. One particular software engineer is assigned to multiple projects. They can do it. And obviously, one project can have many employees. Okay. Many to many. A student can, one student can register for many courses, and one course has many students. Say you are going for a physical tuition class. So there you register for two subjects, two teachers, two courses. And obviously for one course, multiple students come to the class. And student can register for multiple classes, so courses. Many to many. Many to many. So we only thinking about binary relationship. That means two different things. Later we will extend this to ternary and unary also. So then things are getting more interesting, more challenging. Okay, right. So any questions about one to one to many to many, any confusion, anything that you want me to clarify, anything that make you not very comfortable with these three concepts? One to many to many. So if someone says it is many to one, you can always say, okay, look at it from other side, then it is one to many. Okay, then it is one to many. Right. Many to many is always confusing, right? Many to many is always confusing. You need a bit of patience and you need to think about more and more examples. More and more examples. So I'll give you one more example for many to many. Okay. So yeah, I have another two entities. So this is pretty much like this, okay? Say student can, say in a school environment, student can play for many teams or many sports. You can go for cricket, you can go for rugby. Say you are in both rugby team and cricket team. That means one student is related to many sports. Of course, if you take one sport, many students doing that sport. So you can see it's many to many. One student can go for many sports. One particular sport, many students coming for that sport. Again, many to many. It's not one to one. It is not one to many. If there's a restriction saying student can only select one sport, you are not supposed to select multiple sports. So then it is one to many. But usually there's no such restriction, right? But if you take something like A level, right, of course these days some we have the mixed subjects also. So if you forget about the mixed subject, a student supposed to select one field. But these days that thing is also relaxed. Okay. So then it is one to many because student must select one field, maybe technology field, commerce field, art field, science field. But particular field can have many students. So then it is not many to many because there's a restriction saying you are not supposed to be both bio student and commerce student. So that is why we have that mix. You are not supposed directly belong to any of the field. You are doing mixed subject. But you can't go and say I am both in the commerce and bio. No, you are a mixed student there, mixed field. That is one to many there. Okay, one to many. Okay, right. So that is called multiplicity or cardinality. What are the three possibilities? One to one to many to many. Now we are into our second concept related to relationships. Degree of a relationship. So this is another interesting concept, sometimes challenging concept. So degree of relationship is how many entities or how many entity types involved in that relationship. For example, if you say mother and child, two entities, two entities, because mother is different from child, child is different from mother. Right? Student and course, employee and department. Actually, all the relationship we discussed so far are binary relationships or the degree two, because two different its relationship is between two different entity instances. But I told you that things are getting more interesting, more challenging. Why? There are unary relationships as well. There's a possibility of ternary and even n-ary. Okay, so now you need to be very serious. Serious, do some exercises, do some questions, think practically if you want to understand unary ternary relationships. Binary is the easiest to understand. That is why we always, so far, we have been discussing only binary relationships. Binary means relationship is between two different things, two different entities, student and course, employee and department. Binary relationships. The relationship involves two different type of entities, two type of entities. Entity one, entity two. Okay, that is the easiest to understand like this. Of course, it can be one to one, one to many, many to many, because this that is a different concept. That is multiplicity or cardinality. This is degree. Degree is two or binary. So therefore, you can have binary one to one, binary one to many to many. Right? If the relationship involves two different type of entities, this order, this payment is for this order, or this order has payment. Course has subjects. Subject belong to course. Okay. Binary relationships. So then you can have unary relationships. So this is tricky. This is tricky scenario. So unary relationship means there can be a relationship between two instances of the same entity. Two instances of the same entity. Usually in two instances of two different entities. Code and payment, student and course, mother and child. But this is two instances of the same entity. Same entity. Only one entity is involved in this relationship. That is why we say unary. Unary means one. Only one is entity. It's a relationship between different instances of the same entity. Unary relationship. Do we have that kind of relationships? Of course, yes. Okay. If you take something like social media, like Facebook, so if you have a login or user account, you are a member of that social media framework. Maybe Twitter, maybe Instagram. So then a particular member can send a friend request and the other guy accept it. So then a particular member has a friendship with another member. Of course, not one friend. You a particular member can have friendship with many other members. Someone will say, I have 100 friends in my Facebook, Instagram, friends. Particular member can have many friends. And if you take that friend also can have many friends. Okay. So it's friendship is not just one way, right? Friendship is binary concept. X friends with Y friends with X. So therefore, one member can have friendship with many others. And that particular member also can friendship with many others. It's like Nimal has friendship with Kamal, Vimal, Chamal. While at the same time, Kamal has friendship with Nimal and maybe Ravi and Anu. You can see one to many. And this guy also one to many. These guys also have like that. And of course, these guys will also have like that. And it's like a network. So friendship is between two instances of the same entity called member. Say employee supervising another employee. Right? Maybe particular employees supervise three other employees. So this is also employee. This is also employee. Right? If you want, you can look at it as employee and supervisor. But if you look at it as all are employees, so then it is unit. For example, when you are in Montessori or grade one, when you go for a trip or something, outing, usually your teacher will pair you guys, right? So every student in the class is paired with another student. අත්තල්ලන් යන්නේ රත්තල්ලන් ගිහලා එන්න කියන්නේ එතකොට එක්කෙනෙක් නැති වුණොත් අනිත් එක්කෙනා කෑ ගහනවා ටීචර් ඔන්න මගේ පාර්ට්නර් නැතෝ කියලා. That is everyone is paired with another member, right? But that is one student is or one child is paired with another child. There's a relationship. Okay. So those are called unary relationships. Little bit difficult to understand, but once you understand, you will find that okay, plenty of that kind of relationships are there. Okay. But it must be between instances of the same type, human to human, okay, a tree to tree, item to item. Say one engine can have one gearbox. One gearbox can have one engine, but that is binary because engine and gearbox are two different things. That is binary. But how to make it a unary? Maybe a particular plane has two engines. So that is one engine is related to another engine because both are engines. Both are engines. It's not like engine and gearbox. Two engines have relationship. These two engines work together. Okay. Right. So those are called unary relationships. Little bit difficult to understand, but once you get that confidence, it's like by cycling. It's like swimming. Initially, you are very uncomfortable, but after some time, you feel like, okay, now I got it. So then you are very comfortable. Right? So this topic is something like that, right? Unary relationships. Because binary is the easier guy to understand. Unary is the harder guy, but understandable. So the next one is Turner relationship. So these are the very rare situations, very, very rare. And usually we go for, we see Turner relationships under very special circumstances, sorry, under very special circumstances, special situations. Sometimes we look at it in a very special way. So then only you will see Turner relationship. So this is not two binary relationship. Sometimes you get confused. So there can be a possibility A has a binary relationship with B, B has a binary relationship with C. That is not a Turner relationship. That is two binary relationship. This is one relationship, this is another relationship. Right? But this is different. This relationship is between three different type of entities. So they have three different roles, three different concepts, but there's a relationship between these three. Can you think of such an example? I know it's very hard, but if you have a bit of luck, oh, yeah, very critical thinker, you may straight away come up with the correct answer also. But most of the time, if you are new to this concept, your answer might be ended up as maybe two binary relationships, though you feel like it is ternary. Anyone want to give me an example? I don't mind whether it's correct or wrong. There's a high chance your example is wrong, but think about it. So there's a relationship between three things. Between three things. In the A-level exams also, they have given you ternary relationships, even for the second paper. So therefore, you are supposed to understand this. I am studying ICT with yes. In a way, yes. So there's subject is there, student is there, teacher is there, subject is there. So student study the subject from this teacher. Okay. In a way, yes. If you look at it in a very particular way, but in a way, if you look at it in a different way, we can break it into two binary relationships also. Okay. But this is perfectly correct because especially in sort of a tuition environment, this is how it works. This is how it works. Because you have the freedom to select the subject, you have the freedom to select the teacher. That is how the tuition or the private sector work. Right? So you will go and say, I want to study this subject with this particular teacher. So therefore, yes, it's a Turner relationship. But if it is a school environment, this is not actually Turner relationship. That is why I told you that it depends on exactly how it works in the domain. Because in school environment, you study a particular subject or you are in a particular class. Okay. Or you say, okay, I want to study this subject. Say student, say I want to study ICT. Then the school will assign school. No, you don't select the teacher. Right? You select the subject. Then school will assign. Say you have only one ICT teacher in your school. Also, school will assign a teacher for the ICT subject. Right? So teacher teaches ICT. You study ICT because you don't have the control to select the teacher in schools. Right? For example, I can still remember. So when I did my A level, so I wanted to study from a particular teacher, pure maths or the maths at that time, but I never have that opportunity, right? So it's the school that decide which teacher is your maths teacher. So therefore, it is not ternary. It is two binary relationship. But in tuition environment, yes, this is a ternary relationship. Actually, that's a very good example, right? Very good example. Right. So this is another example. Again, this depends on the way you look at it. Say that there's a particular product, say fan, washing machine. Those are products. Iron, blender. Then there are brands. Say Usha brand, Cecil brand, LG brand, Samsung brand. Okay. So then we have stores. We have store in Colombo. We have store in Jaffna. We have store in Kandy. Say now I'm interested in now remember it's something like Singer, right? We have stores in different part of the country, and we sell different brands different items from different brands. Say Avans, so they have Sanyo TV, or say they have LG fridge as well as maybe some other type of fridge, right? Other brands. So they have LG fans, Pusha fans. So then if you want to keep track of how many LG washing machines are in Colombo store, how many LG washing machines are in Colombo store, then how many Samsung washing machines in Colombo store. That is a different thing because it's combined three concepts. Samsung washing machines in Colombo. Then how many Samsung washing machines are in Kandy? Okay. So it's I always combine three concepts together. It's like student, teacher, subject. So then it is a Turner relationship. It's not two binary relationship. It's very hard when someone is new to database modeling, differentiate between whether it's two one-to-many relationships or two binary relationships or one Turner relationship. So how do you find it? When you must, there should be something you are interested, like how many elements. So we can see how many LG fans in Colombo. So then you can say LG fans in Colombo. So therefore you need Turner relationship. Turner relationship. It's not two binary relationship. Right. So just think about it. I just gave you a start. When you do exercises, challenging exercises, then you can see whether your answer is correct. So then you need to think why my answer is not correct. Maybe I thought it in a different manner. Right. So that is called ternary. Binary, unary, ternary. Okay. So binary is the easiest. Unary and ternary are little bit challenging to understand, identify. Remember, so far all our relationships are between strong entities, student and boss. Okay. Employee and department, major concepts. So there can be a relationship between major concept or strong entity and weak entity. Strong entity and weak entity. So remember, spouse, we are not much interested, but at the same time, we need spouse details, maybe when there's a insurance claim. health insurance claim. So therefore, we have no option but to keep spouse details. But spouse is not a major concept for the our organization, employee management system. But we need spouse details. So therefore, we mark it as weak entity, right? So we don't care about parents because we don't teach to parents. But in case we want to inform something about the student, we need parents' information. So therefore, parent is a weak entity. Student is our major concept in student management system. So in that kind of case, again, we have parent is or guardian is your weak entity. So when there's a relationship between a strong entity, right, strong entity and weak entity, like employee and spouse, student and parent. So we say that we have a weak relationship. So then we create, usually our relationship is a diamond shape. Now our relationship is also double diamond shape, double line. And also this, the relationship's weak side is also connected using double lines, double line. But strong side, you keep it in a single line. And strong entity is obviously single line. Now, not only the weak entity is double line, its relationship is also now double line. So that is how you model it. That is how you model it. Okay. So this double line has another meaning also, which I will explain later, like what is show partial versus total. But for the time being, just remember when we have a weak entity relationship with strong entity, that relationship is also weak for the weak side. On this side, you just use single line. Okay. So now now you know how to model between strong to strong entity, strong to weak entity. If you can give me an answer for this one, so you have understood this perfectly. But if you can't give me an answer for this one, you are perfectly okay, right? This is I'm asking very right. I'm thinking whether you have sort of a superb thinking, extraordinary thinking about our subject. Can't we have relationship between two weak entities? Two weak entities. Two weak entities. Can't we model relationship between two weak entities? If yes, why? If no, some reason that comes to your mind. I don't mind whether it's a crazy reason also. Yes, also you need to say because of this possibility, I say yes, it's possible. If you say no, again you can't just say no, you need to give me some reason that whatever comes to your mind. Whatever comes to your mind. So if you give me an answer, it's a bonus. By default, I don't expect that anyone gives me the answer, correct answer. But if someone can give me the answer and if it is correct, I will take it as a bonus. Sometimes when I ask question, I expect that everyone give me the answer, but this is something that I don't expect anyone will give me answer. But if you give me answer, it's a bonus. Bonus for me. So can't we have relationship between two weak entities? Or it's very rare. If it is very rare, we hardly have this kind of relationship models. Think about it. I will give you another 30 seconds to think about it. Now, don't ask this from ChatGPT, okay? ChatGPT will give you answer. Why it is very unlikely. So the answer is very unlikely. Can happen very rarely, but in general, we are not supposed to model relationship between weak entities. But in a very extraordinary situation, very special scenario only, we may have it. I can't say not at all, but 99.99 times we may not have relationship between weak entities. Why? Remember, weak entities are not our direct entities. These are just stay there due to some other our strong entities. So then are we interested about these connection between these weak entities? Because weak entities means which are not much of interest to us other than their relationship with our strong entity. So then who cares about relationship between these two weak entities? Because those relationships are not something we are interested. Actually, we are not much interested about these weak entities also, just in case we keep those details, because sometimes we need it, though it is not a core thing. So then obviously we are not much interested about their relationships, right? Okay, shall we ask ChatGPT what kind of answer ChatGPT gives? First, I will ask can. Of course, it might say yes, but it will say very rare. Can we have relationships with two weak entities in ER modeling? So this subject is not memorizing. This subject is all about thinking. Okay, so if we say maybe yes, right? Yes, we can have, but there are important constraints and considerations. Okay, yes, we can, but there are a lot of constraints and considerations. Okay, so you can see under these special cases only there can be. Okay, there can be. So in general, no. Why? Because those are outside our interest. These are outside our interest. Okay. Very rarely. Actually, I haven't seen single mapping of weak relationship between two weak entities. Okay. In any question, exam papers and nothing. Okay. Or in real world. Okay. Right. So therefore, you can have relationship between two strong entities. You can have a relationship between strong entity and weak entity, but not between weak entities. Very rare. Almost never. Okay. Right. So our next concept is associative entity. So this is also related to relationships. Right. So another name for relationship is association. Right. So when we have something like employee and department, we say there's a relationship, right? Another name for relationship is that we can say there's an association between employee and department. There's an association between student and course. So therefore, association is another name for relationship. So then what is mean by associative entity? So remember, association is something like a relation. Actually, it's a relationship. So then it's like a relationship entity. So that means your relationship ended up as an entity. So your relationship has the bit of a features of an entity or nature of entity. So then you call it associative entity. In your A-level ICT, usually we just show it like this. But in some books, we show associative entities like this. You can see it is association or relationship. At the same time, it is entity. But in A-level ICT, I haven't seen that representation. Your examiner will just show it like this. But there are hints. That is, if usually you are supposed to have attributes for entities, right? Entities. But you will see in rare cases there are attributes for relationship. If there are attributes for relationship, there's a big chance that this is associative entity. Now, this is the most advanced concept related to ER modeling. Okay, one is ternary relationship, unary relationship. Other one is what is this associative entity, and how can we have attributes to the relationship? You can think of attribute to the entity, right? Student entity, student ID, student name, contact number, address, course ID, course name. That makes sense. But does it make sense to have attributes to a relationship? Attribute to a relationship. Okay. So usually you can have attribute to a relationship when it is many to many relationship, but not always. Sometimes, if it is many to many, there's a possibility that your relationship has attributes. So your relationship is associative entity. So second possibility is when you have ternary relationship. Ternary relationship, there's a high chance that not only you have attributes here, there's a possibility that you have attributes here. So then again, it is associative entity. So what are the two possible probable places where you can end up with associative entity or some attributes in the relationship? Many to many relationships, binary, unary, ternary, whatever. And in general, if it is ternary, there's very high chance of your relationship is or your association is also ended up as entity. That means you have attributes there. Those are the two main scenarios. Okay. So when many to many relationships, ternary or higher order relationships, we don't consider more than ternary because we can, if you want, you can extend it to four entities, five entities, that is something like this. But our A-level ICT, we only look at maximum three. If you want, you can extend it to four and say it's a in a relationship where n is four, or you can say five. But we only concentrate on maximum of three for ternary. Okay. So, what are the possibilities of associative entities? By many-to-many relationship, whether it's unary, binary, or ternary, and in general, ternary relationships or higher. That is where you can right, not always. You can end up as associative entity. That means your relationship is also represented by a table later or entity. This is the hardest part. Okay, this is the hardest part. So therefore, if you have any questions, you need to ask. You can ask from me, you can ask from ChatGPT, do a lot of research questions, past paper questions. Right, so this is an example of a many-to-many relationship. Employee can work for many projects. Project can have many employees. So employee ID is our identifier, employee name, maybe employee salary. Right? You can have additional attributes. Then project ID, project name, maybe project location. So those are the project related attributes. And remember, this is many to many. So let's assume we want to keep track of how many hours particular employee work for a particular project, because particular employee can work for many projects. And obviously one project can have many employees. So my requirement is I want to keep track. For example, I have Nimal, Amal, Kamal, say project 1, project 2, project 3. Say Nimal work for project 1 and 2, Amal work for all three, maybe Kamal work for only project 3 or project 2 and 3. So then I want to keep track of how many hours Nimal has worked for project 1, how many hours Nimal has worked for project 2, how many hours Amal has worked for project 1, how many hours, not total number of hours Amal has worked, how many hours Amal has worked for project 1, how many hours Amal has worked for project 3. So now if I need that information, can I put it here? Because if it is Amal's name, yes, Amal's salary, yes, but you can see how many hours Amal worked for this B project. So therefore, you can't put it there because it's related to project also. Can I put it there? No, right? How many hours Amal has worked for project one? Project 10, Amal both are there. Of course, I can say project name, project location, project budget, but this is how many hours Amal has worked for this project. You can't have it here. You can't have it here, you can't have it here. Because this concept combine employee and project. How many hours Nimal has worked for project 2? So therefore I can't add it here. I can't add it here. So then I have no other option but to put it there. Hours work. That is how many hours a particular employee has worked for a particular project. So therefore there's a possibility of your relationship or get ended up with some attributes. But that happens only when your relationship is many to many or it's a ternary relationship. In other cases, you don't get that kind of possibilities. Is it clear? Right. So later on, when we move to design part, you will learn that not only we are going to have tables for these entities, we are going to have table for these associative entities also. But normal relationship, you don't need table. But if it is associative entity where you have attributes, in designing, you will find that we need to add separate table for that. We call it connecting table. So that is why we are interested in whether it's there are attributes for this. Okay. So this is another example. Student can register for many courses, or student can follow many courses. Course can have many students. So student ID, student name, student attributes. Course ID, course name, course fee, say particular course fees, say 20,000. So then what about date of registration of a student for a particular course? Because a particular student can register for multiple courses. So then say Nimal registered for chemistry course January, and Nimal registered for biology course in March. So we need to keep track of the date of registration and maybe course fees also separately. So Nimal is paying course fee for particular course, say machine learning, monthly or part by part. Now he has paid for that 10,000. He is following another web development course. For that, he has only paid 5,000. So we need to keep track of for which course, for which student has paid how much. So then that must also be here, right? So that means it's many to many, and there are some attributes which is related to both. So, so this is an associative entity now because we have attributes. Because these attributes you can't put it into here or there. Is it clear? Is it clear? If it is not clear, you can ask from me, you can ask from ChatGPT. You can talk to ChatGPT also, right? So start talking because it's more fun. It's more uh, practical. But there are situations you need to chat because you can take your time and read it. Sometimes what you need is, it's like talking to your teacher. You keep talking, follow up questions. Okay. Sometimes you can challenge because it's a machine. So don't act in a rude way with your chat GPT, but something that you can't talk to your teacher, you can talk to your chat GPT. Sometimes you can challenge. You can be very aggressive with your chat GPT. Not because you hate chat GPT or whatever the chat agent, but just to you are very aggressive so that you want to challenge. Actually, you want to challenge yourself. Okay. So you can ask, can't we put fees in the cost table? So then ChatGPT must give you a good explanation, right? Of course, you can't put it because then it is related to course. So you can't track it student wise. Right. So that is many to many example, possible associative entity. So remember the other possibilities when you have ternary relationship. For example, how many Samsung washing machines are in Colombo store? So that quantity, can you put it there? No, that is not washing machine count. If you want to count how many washing machines are there, yes. For each product, how many you have? Here. For each brand, how many you have? Here. Each store, how many you have? That is total washing machines in Colombo. But if you want to keep track of how many Samsung washing machines in Colombo store, how many LG fridges in can be stored. So then that quantity must come here. And later that quantity will get into this particular table. So not only three table, you will end up in fourth table, and that will be here. Here also in many-to-many relationship, always we introduce another table. We call it connecting table that we will be discussing when we do designing. And we will be adding these fields to this connecting table because that is where naturally it should be. Okay. So our task is identify whether it's associative entity, whether it's one-to-one, one-to-many, many-to-many, ternary, binary, unary, so that the designers can do the needful, correct things. So designers know how to model your one-to-one relationship, one-to-many relationship, many-to-many relationship, associative entities. Of course, designers know means you will learn those things in our next session, not today. Designing, because we are going to start designing in the next class. Okay. So here you need to identify, yes, it's associative entity. Yes, it's a weak entity. Yes, it's a derived attribute. Yes, that is the identifier. Okay. Right. Any questions? Because now we are almost done. We are almost done with modeling. Any questions? Any questions? Right. Before moving to extended DR modeling, that is also in your syllabus anyway, I want you to do this exercise. Okay. So this is exercise. So in the exams, you get these kind of questions. They give you a case study or scenario and ask you to draw the ER diagram. I will show you a past paper question. Okay. Almost every year you get these kind of questions. Almost every year. Right. So this is a design question. This is not to draw the ER diagram. Okay. Let's take a different paper. This is a design question. Uh, Say this paper. So this is again partially design, partially analysis. This is not a full analysis question. Part is there, but it, they have not asked you to draw it. Okay. They have not asked you to draw the full diagram. So maybe this year. You can see here. This is the scenario. The candidate who have been selected to university entrance should register for the given blah blah blah. Right. Then they talk about the scholarship, Mahapala scholarship, bursary, blah blah blah. And also students are given laptops by the government, blah blah blah. Right. So then they say draw an ER diagram. Right. You can see draw an ER diagram. That is your question. That's all, nothing else. That's all. So now let's see the answer of that question also, because I want to prepare you for that kind of a challenges. Right. Say marking scheme. So they expect this kind of a year. Actually, this you need to rotate something like this. Right? Identify entities, relationships. You can see associative entity. You can see some attributes. Actually, this is minute one, but sometimes examiners add attributes to that also. But usually, this should not be the case. But this is a little bit debatable thing because it's minute one, right? So that also can happen. Okay. So examiner has mentioned that okay, this is not required, even though examine students have not drawn this, give full marks. So that can also happen. Okay. So as a starting point, so let's do this one. Right. Take a piece of paper. Okay. Read this and draw the ER diagram according to your understanding. That is fine. If it is not correct, that is fine. Maybe 80% correct. Some parts are not correct. But take a piece of paper and draw it. Right. Do it. The vendor has many products. Customer can make orders. Now, these are the possible entities, right? Vendor has many products. Customer can make orders. Each order may have multiple load items, like a bill. Customer can make payments to the order. Order we have dimension. That means part payments are allowed. That means you can pay it by part, like buying a washing machine and pay by parts. Right? So draw an ER diagram. So this question has not given you any attributes. You can just think of one or two possible attributes, especially identify attribute. So then how these things are interrelated. How the product is related to customer is related to order is related to order item. Oh, if there's, I'm not saying that always these are related, right? So is there a payment related to something? So to which entity products are related, to which entity customer related, to which entity order related, order item related, payment related. So there will be about four, five, six relationships. But if you can identify at least two or three, that is good enough out of these five, six relationships correctly. Just use your common sense. Right? Draw it, ER diagram. And try to add one or two attributes and specially identify. For example, you can say customer ID, order ID, payment ID, product ID, something like that. Maybe just one attribute like customer name, product name, maybe payment ID, payment date, payment amount, something that makes sense to you. Right? Draw it. Because this is what you're supposed to do in exams. Not like this, they give you big scenarios, right? Okay. And you need bit of experience. That is why we are doing this to get that experience. So I'll start with customer. Okay. I'll start with customer. Just singular customer. So customer can make an order or do an order. Customer is always related to order, right? Obviously. Customer make an order, make or whatever. Okay. So, for example, when you go for the supermarket also, it's basically your order, right? Your bill is your order. You order something. Say you go to the restaurant, you order maybe something like a soup and say rice and curry or fried rice or noodles or maybe another dessert. So that is your order. So then your order has items, right? So you order soup, rice, chicken, maybe salad. So your order has items, right? So that is usually we call it order items. Order items. Order items. Because your order has items. Wait ලියාගෙන යන්නේ මේවා කියලා. පිටු සුපර්මාකට් එකක් නෙමෙයි restaurant එකක් කියලා. So then your order items is related to items because your restaurant has different items, fried rice, chopsy, noodles, soup. So those are items. Items that they provide in their restaurants. So item is related to order item. And then you do a payment. So this payment is for this order, right? You are paying this order. ඒ කියන්නේ බිලත් එක්ක payment එක කරන්නේ. Right? So this payment is by for this order. And if especially if it is a restaurant or whatever, they don't care who's their customer. They are interested in whether this order is paid or not. Paid or not. Okay. Say I go with another two guys to the restaurant. They don't care whether Nimal did the payment, Kamal did the payment, as long as one of these three guys did the payment. Actually, in this case, they don't care about the customer also, but maybe customer is the one who make that reservation, saying that okay, three of you, we come into your restaurant, please reserve a table. But payment can be done by anyone. They are interested whether this order is paid. So therefore, I'll add it here. Payment. Of course, you don't do the payment item by item. You pay for the bill. But if you connect it to customer, I'm also okay with that. Maybe then the restaurant is interested in who did the payment also. Okay. But usually restaurant is interested in whether this order is paid or not. Okay. So this is my relationships. Customer, order item, payment. Maybe customer ID, customer name, order ID, order total amount, order date, payment amount, payment date and time, right? Then item ID, unit price. So this is order item ID, item quantity, and the amount for that item. Say two soups, one soup is 500, then 1000. So likewise, you need to, now this is high level. Customer is related to order is related to payment, order is related to order item, each order item is related to item. Because from item you can get the unit prices and so on. This is valid for a supermarket also, or something like a single shop or barn shop. You need bit of experience, right? So you won't be able to straight away do this, right? But with experience, you will be able to do it. Right? I have not given the names for this. Actually, I have forgotten to add. We should have some customer make an order or something. Okay. Order is related or payment is for a order. Order consists of order items. Order item relate to a product and something like that. Make sure you have identifiers and maybe one or two attributes. Of course, if it is in the exam, they will give you the attributes also most of the time. But you are free to add an optional attribute. Okay, right. Any questions? Right, now we move on to the extended DR diagrams. Extended DR modeling. So this is also in your syllabus, specifically mentioned in your syllabus, extended DR. So what is mean by, now what we did for so far is ER modeling, entity relationship modeling, which is part of requirement analysis. So requirement analyze and model the data. Better understand the data related requirements of the organization. That is what we are doing. Still we are not doing any designing. Right. So remember I told you that we used to have network databases, sorry, hierarchical databases, 1970s, then network databases. So then came the relational databases. Now remember this ER modeling is for relational databases. Right now, the most widely used type of databases are relational databases. But so remember these relational database concepts came in 1980s, 1970s and 1980s. But in 1990s came object-oriented programming. Right? So object-oriented programming came later. By the time we have been using relational databases. So then they thought, how can we support object-oriented concepts in our database? So the object-oriented concepts involve something like inheritance, polymorphism, encapsulation, abstraction, especially inheritance. The major concept is inheritance. So then software engineers and designers start, of course, the databases, we can, bit of relational databases, we can support object-oriented concepts, especially inheritance. So therefore, when we see there's a possibility of inheritance, We must model that so that in the designing stage, you proper design it. You proper design it. So in order to support that, ER models start supporting some inheritance related concepts. So then people call it extended ER modeling. That is, to the normal ER modeling, you add some object oriented concepts also, and we model that also. So then we call it extended ER modeling, EER. Okay. There are a lot of object oriented concepts. Object oriented programming is not in your A-level ICT. Okay. So therefore, you don't need to go into serious level, but the basic understanding. Okay, basic understanding. Even in your programming, we don't do much of object oriented programming. Right? Just a tiny bit of object oriented programming. Just a gentle introduction. What is a class? What is object? Okay, that's it. Right. So therefore, in order to support object-oriented concepts, modeling object-oriented concepts in our relational database model or model, so that designers can support object-oriented, especially inheritance in our databases, we can now model those concepts. So then we say we have extended DER diagram. Especially we are interested in inheritance. Inheritance is one of the main concept in object-oriented programming. So therefore, first of all, you need to understand what is inheritance. And what is inheritance? For example, you are inherited from your father and mother. So this is where the terminology comes. Right? Inherit. It's related to biology. Even trees inherit from their parent tree. Parent tree. So the child tree has the features of the parent tree. That is called inheritance. But in object-oriented programming, the word inheritance has some similarity with the biological inheritance. At the same time, it has differences as well. So therefore, don't always think that inheritance in programming is 100% same as inheritance in biology. No, there's a bit of similarity and plenty of dissimilarity also. Okay. So the number one dissimilarity is in biology, inherited thing is children, right? Your pet, you inherit from your mother, father. A particular tree inherit from its parent trees. So it's child and parent relationship. So child is given the birth by the parent. But in object-oriented programming, there's no children and parent. Sometimes we use the word children and parent, but in reality, it's simply generalization and specialization. There's nothing like the children is born from the parent, right? It's like you were born by your mother. But in object oriented, there's nothing like that. In object orientation, rather than children and parent, it is specialization. Specialization. So subclass or subtype is a special case of the general type. It's not children. Sometimes we use the word children and parent, but it's very misleading. So the better word is supertype, subtype. Loosely parent, children. But in a very professional manner, just call it supertype, subtype. Because subtype is a special case of supertype. Because when you go down in the inheritance, it's specialization. So you can have another specialization. Right? It's a hierarchy. Okay. Say current account is a special case of account. Savings account is a special case of account. Also, you look at from biology. Dog is a special case of animal. And cat is a special case of animal. But that is little bit misleading because no, that is not misleading because cat is not the children of animal, right? So remember, we don't talk about parents and children in programming. When I say cat is inherited from animal, it is not cat is a child of animal. Cat is a special case of animal. Dog is a special case of animal. Then Alsatian dog is a special case of a dog. Okay. Rottweiler dog is a special case of a dog. So it's all about not children and parents. It's all about special general. Okay. Savings account is a special type of account. So then there can be a special type of savings account called, say, super savings account, senior citizen savings account. So these are not senior savings account, these are children of savings account. No. Senior savings account, senior citizen savings account is a special case of a saving. Is it clear? Because number one is you need to understand inheritance. If you don't understand inheritance, you will never understand extended DR money. So the very important thing is, though we loosely call parent child, that is very misleading. The best way is special case, general case, or super type, subtype. Okay. When you look at it from top to bottom, it is called specialization. But if you look at it from bottom to top, it is called generalization. Okay. Right. So when it comes to ER modeling or extended ER modeling, basically we want to model inheritance, specialization, generalization. So when we model specialization, generalization, there are few concepts we can additionally show or model. In your syllabus, in your A-level ICT syllabus, they have only considered two properties, two special properties, how to show them in your extended ER diagram, which are related to inheritance. That is disjoint versus overlapping. Right? We use the word specialization or generalization, right? Other concept is total versus partial specialization. So that means specialization or inheritance can be disjoint or it can be overlapping. It can be total or it can be partial. So therefore, there are four possibilities: disjoint total, disjoint partial, overlapping total, overlapping partial. So there are four possibilities at the end. So when we say we have inherited relationship, so that relationship can be disjoint total or disjoint partial, or overlapping total, overlapping partial. Okay, right. What is mean by disjoint? What is mean by overlapping? Because these two are the related concepts. Disjoint versus overlapping, total versus partial. Okay. So every inherited relationship specialization is either disjoint or overlapping. Every specialization is either total or partial. Okay. Right. What is mean by disjoint? So this is how you specify disjoint inheritance or specialization using D. So disjoint is not a new word for you. If you have learned in maths, you may have heard the word mutually exclusive, अन्योन्य वशයෙන් बहिष्कार. That is disjoint. For example, if you take two sets, you have learned this in your O level. So these two sets are disjoint. But these two sets are not disjoint because there are common elements. This is disjoint. So that is how where the word comes. This is joint sets. Right. So then what is mean by disjoint? Remember we have this general case, special case. Disjoint means this general case belong to maximum of one special case. not more than one. So then it is disjoint, right? This general case belong to maximum one special case, not more than one. If it is more than one, it is overlapping. That is why we say every specialization is either disjoint or overlapping. It can't be both disjoint and overlapping. So then how do you decide whether it's disjoint or overlapping? Look at the reality. Look at the business domain. Look at how these things are actually related in the business, in that problem domain. Then you will understand whether it's disjoint or overlapping. Or if it is exam question, they will give you some hints. They will give you some information to decide. Okay. Right. For example, say we have inheritance or specialization. So employee is the general case. But every, say employees can be specialized as technicians, typist, manager. Let's say this is a very small organization. You have only technicians, typist, manager. But all are employees. All are employees. Now let's assume it is disjoint. If it is disjoint, this is how you model it. D within a circle, then your sub types, special types. So disjoint means when you have an employee can't belong to multiple specializations. It's disjoint. Your employee can be technician, then your employee is not a typist or manager. If your employee is special case of an employee that is a typist, then your typist is not technician and manager. That means you can't have an employee who is both typist and technician, who is both typist and manager. Your employee can maximum belong to one special case. So then it is disjoint. It's very easy. Very, very easy. Okay. Is it clear? So that means your super type can belong to one of the special cases, not more than one. Maximum of one special case. Then it is disjoint. Because then it is something like this. Either this belong to this. If it is belong to this, it doesn't belong to these two. If it belongs to this, it doesn't belong to these two, and so on. Okay. That is called disjoint. So you need to look at the reality, or you will get some hints from your question. And then you can decide, okay, that is disjoint. D. Okay. And if there's a possibility that a particular employee belong to multiple categories, so some other example, then it is overlapping. So then we use O. O. That means your supertype can belong to more than one subtype. Say this is a part, say this is a factory or something. You manufacture certain things. Say that part can be manufactured or purchased or both. The manufacture means you produce. Purchase means you buy it. So then someone will say always either you manufacture it or you buy it. But assume that there's a possibility you purchase it and then do some modification. So then it is both purchase and manufacture. You buy it, but then you do some modification. That means we are manufacturing again. That means the part can be both manufactured and purchased. If that is possible, then it is overlapping. It is not disjoint. But if there's a policy saying either you fully manufacture from beginning or you buy it but you don't do any changes, so then it is disjoint. But this is we have taken it as overlapping because product can be purchased and then do some modifications. Under that assumption, it is overlapping. So under this assumption, that is why in the exam question they give it to you. They give you enough hints, right? So is it clear? Is it disjoint? Overlapping. Okay. Right. Don't think about this double line. Double line comes from the other concept. Okay. Other concepts. I will give you an example. You need to decide whether this is disjoint or overlapping. Okay. So I have say we have animal. So we say we have animals. So animal can be dog. So we keep dogs and we keep cats. My question is it disjoint or overlapping? Common sense. Common sense. What is your answer? Is it disjoint or overlapping? So we have animals, say it's a zoo or something. So we keep dogs, we keep cats. Or this is a animal shelter. We take care of animals. When you go outside, you go on a trip, you can keep your animal with us. We take care of dogs and cats. Now tell me, remember dog is a special case of animal. Cat is a special case of animal. Is this disjoint or overlapping? No one? Don't worry. If it is wrong, that is fine. Right? So it is disjoint, right? Animal can't be both dog and cat. Right? Your animal is either dog or cat. You can't say my animal is half dog, half cat. So therefore, this is disjoint. Okay, this is disjoint. Okay, right. Say we are doing some services. We are we are doing some services to pets. Say services, service. So our services can be grooming, grooming can මොනවාද ක්ලීන් කළා අනවශ්‍ය බූල් කපලා දාලා එහෙම දානවා. And also we do a service uh, that is uh, let's say we give a service that is uh, health check. We do health checks. So our service can be grooming, health checks. Now is it disjoint or overlapping? So when an animal comes, so we can do grooming, we can do health checks. So then our service can be grooming, our service can be health check, or our service can be both. Right? So maybe we take an animal to do both grooming and health check. So then it can be overlapping because our service may include grooming and health check. First we do the grooming and then we do health check. But some animals we just do the grooming and give it back. Some animals we don't do grooming, we just do the health check. So therefore these are two special cases of services, but there is a possibility of overlapping. So then it is overlapping. Okay. Right. So that is disjoint versus overlapping. Say you have account. Say in the bank you have current account, savings account. Is it disjoint or overlapping? Account, current account, savings account. Disjoint or overlapping? Right. Current account, savings account. Disjoint or overlapping? DOO. If you have little bit idea about accounts, banks, you must have the answer. That is disjoint. Your account can't be both savings and current account. Either you have current account or savings account. So your account is cannot belong to both. It's a disjoint. Disjoint. Right. Now we move on to our next concept. That is disjoint versus overlapping. Our next one is partial versus total. Total specialization, partial specialization. Okay. So you can't have both total and partial, just like you can't have both disjoint and overlapping. So total specialization means every entity in the superclass or supertype must be member of at least one subtype. Right? So whenever you have a supertype, it must be a member of at least one subtype. That means you can't have an entity which is only belong to the supertype, not to any of the subtype. If so, we represent it using double line. Double line for this part. Then this can be DO depending on disjoint to overlapping. But double line means it is total. So that means whenever we have a special case, it belongs to one of the subcase also. Okay. So here we can see we have used double line. So that means whenever we have part, it must belong to one of these. It can't be just a part. It must one of these also. It's like account, savings account, current account. So whenever we have account, it must be either current account or savings account. There's nothing called account. There's nothing called account which is neither savings account, current account. So whenever we have instance here, it must belong to one of the specialization. So then it is total. Every part must be either manufactured part or purchased part in this case, this example. Okay. But there are situations it is partial. That means there can be a special case without it belong to one of the, sorry, there can be a general case without it belong to at least one of the special case. Right? Can that happen? Yes. Say this is student. And your student can be either scholarship student or bursary student. Bursary. Actually, this is from one of your past paper question. I remember I showed you. So they mentioned some students get scholarship, some students get bursary. Bursary is a when you go to university, you know that Mahapola scholarship and so on. So some students get the scholarship, but some other students they don't qualify for student scholarship. Maybe they are qualified for bursary. Bursary is from a special fund from the university. They give sort of a scholarship again, little bit less amount. So then some students get scholarship, some students get bursary. Usually they don't give both because that is unfair. Therefore, it is disjoint. But now this uh, total or partial. So total means every student must be either scholarship student or bursary student. But if there are students who do not get both scholarship and bursary, so then it is partial. That means you can have students which that student does not belong to any of the special cases. That can be the case, right? So there are some students who go to the universities, they don't apply for scholarship or bursary because they have enough money. Their parents can take care of their education. So then, of course, it is partial. Partial, no double line. No double line. Okay. So therefore, you can have partial disjoint, partial overlapping. Then you can have total disjoint, total overlapping. So you can think of four scenarios: partial overlapping, partial disjoint, total overlapping, total disjoint. So write down four scenarios. So this is an example for partial overlapping. This is an example for partial disjoint. This is an example for total overlapping. This is an example for total disjoint. So if you want, you can just write it to your chat WhatsApp group, your own scenarios, just textual explanation. Or you can draw four diagrams like this. One is, now this is partial disjoint, but don't take any of these examples, your own examples. Four ER diagrams, extended ER diagrams, one showing partial overlapping, partial disjoint, total overlapping, total disjoint. Four ER diagrams. And few attributes also. But partial, make sure it's single line, total double line, and here D O O. I do it as exercise. If you want, you can put it into WhatsApp group. Then I can check whether your answers are correct as well. If not, you can just check it, or you can put it into ChatGPT and double check also. Right? And if you cannot do it, you can ask ChatGPT to generate that also. But don't do that, okay? ChatGPT will generate any number of any of these combinations. Right, so that's it. So now we are done with uh, modeling, analysis modeling. Okay, not designing, not designing. So we have finished this topic, subtopic. Last time we started. Now we have finished. I can't say half, about one third of your database because we have three more topics. And these three topics take more time because these are designing and development. So these three topics take more time. But remember, these are the three big topics. Then your syllabus is almost done, right? Now we are into the three big topic: database, programming, web development. These are nothing, right? We can do this in 2 days. This can in 2 sessions. This will take about 3 to 4 sessions. But these are just 2 sessions topics. So these are the big topics. So then it's like your syllabus is all over. Okay. Right. So we stop at this point, right? Thank you. So if you send me or the WhatsApp group your ER diagrams, I will definitely give you the feedback. Okay. Right. We stop.